Hi guys, this is Joshua again from Motivao Online Instructors. Today we're going to be talking about the 1998 Harvard MIT Math Tournament for question number 7 of the calculus part. The question says, a parabola is inscribed in an equilateral triangle ABC of side length 1, in the sense that AC and BC are tangent to the parabola at A and B respectively. Find the area between AB and the parabola. Well, this is a diagram showing all that information. The orange part is the area that we want to find. This blue line is the parabola, and this equilateral triangle is of side 1 in length. Now, for simplicity, I wrote A in the origin. That means that since it's 1, B has to be 1, 0. And now, what is C? Well, we know that C is in the middle, right? So the X value is 1/2. But how I found the Y value? Well, if you notice, this equilateral triangle, if you divide it by 2, makes 2 right triangles. So how to find the Y value? Well, we know that the hypotenuse is 1, right? That means by Pythagorean theorem, this is 1 squared equals, well, 1/2 squared plus h squared, which is the height that we want to find. Now this becomes what? 1 minus 1/4 equals h squared. But what's 1 minus 1/4 equals 3/4, which intends h equals square root of 3 over 2. And that's how I found this point. Now that we have that point, we can find the slope of these two lines. Slope, let's call this M1, and let's call this slope M2. So M1, by the slope formula, is square root of 3 over 2 minus 0, 1/2 minus 0, which is just square root of 3. By the same reasoning, M2 is square root of 3 over 2 minus 0 and 1/2 minus 1, right, which is the point of B. So this is going to be square root of 3 over 2 over minus 1/2, which is going to be minus square root of 3. Now, why is it so important to find those two slopes? Well, because the question states that AC and BC are tangent to the parabola at A and B. Well, being tangent means that the slope of the derivative, which is the slope, is going to be equal to that slope in particular. But to find that, we need to find the derivative of the function. Now, what is the function that we're looking for? Well, the function of the parabola. Now, how do we write a parabola in the general sense? Well, y equals ax squared plus bx plus c, right? So we need to find a, b, and c to know the parabola. Well, we know that y passes to the 0, 0 point. So y of 0 equals z, which is just 0. So we already know it's c. Now to find the next 2 points, a and b, let's take the derivative. dy dx equals 2ax plus b. Now, if they're tangent to AC and BC, we already know the value of those tangents, right? It's m1 square root of 3, and 2 equals minus square root of 3. So for the tangent of the point 0, 0, which is square root of 3, is just 2a times 0 plus b, which implies that b is square root of 3. Now, we can find this a by plugging in this slope in the derivative. So dy dt, dx, evaluated at 1, 0 is equal to minus square root of 3, which is equal to 2a times 1 plus b. But we know the value of b already, which is square root of 3. So this implies square root of 3 minus square root of 3 equals 2a, which is minus 2 square root of 3, 2a. Now we divide by 2, and we have that a is equal to minus square root of 3. Now we have all three values for the parabola. So we can rewrite y as a is x squared, which is minus square root of 3x squared, plus bx, which is square root of 3bx, plus c, which is 0. Now, why do I want that? Because to find the area under the curve is the integral. So the area is going to be the integral from 0 to 1 of this parabola. Which is minus square root of 3x cubed over 3, square root of 3x squared over 2, evaluated from 0 to 1. But when we evaluate 0, it's just 0, so we just have to evaluate at 1. Which is square root of 3 over 6. And that's our area, guys. Thanks again for watching. This is Joshua from motivao Online Instructors. Please subscribe us at motivao, Facebook page motivao, and our website at www.motivao.com. Thanks again.